Alrighty, CNT125, Chapter 10. We're on the last little section here on wireless network security. We remember, hopefully, from way back in Chapter 6, WEP what is basically your shared encryption key, and with that, it was easily compromisable because it's the same key used for everybody, so I could intercept that, crack that, etc., etc. Along came WPA to help improve that, and WPA2 to help improve that even further, which we'll talk about in a minute. WEP offered only two forms of authentication, the open or shared key. Open is basically, okay, anybody. Shared key is, okay, I need to at least know a password to get in. With your open system interconnection, no key is used at all. Wireless access client, all you need to know was the SSID. Okay, let me get in. Single use code. Okay, there you go. So really no authentication occurring. It's kind of like open. Anybody can use, so to speak. With your shared key, we all use the same key, which is then used for encrypted transmission. So if I crack it, then I have access to all the clients on the network. So that was not very secure. IEEE developed a new wireless standard, IEEE 802.11i, and that was the WPA and later WPA2 to help with our better wireless security. With IEEE 802.11i, it incorporates encryption key generation and management known as TKIP, and you still do see this from time to time on systems. With this one, we had a key for every transmission. It assigns every transmission its own key. I started to say that backwards. In this case, it's helping to improve the security. So it wasn't just a single key used for everything. Now it's okay. Every transmission has its own key using something like RC4. It's now in secure encryption cipher, but again, when we had WEP, going to this was a heck of a lot more secure than what we had previously. TKIP was a quick fix designed to help improve WEP. It was not meant to be kind of the long haul thing, but it was an improvement too. There is still some TKIP used, WPA TKIP used, but it was meant to really be a quick fix for the WEP. WPA was replaced by stronger technologies, updated WPA2, and you also still run into the counter mode with CBC, cipher block chaining, message authentication code. Okay, so this one improves wireless security with newer devices that can use WPA2. TKIP was meant to be backwards compatible. CCNP is meant to be future focused, getting us down the road further. With CCNP, helps with confidentiality with both encryption and packet authentication by providing message integrity and encryption. And this delineates, ensures incoming packets are coming from a declared source, and then also provides faster, more secure encryption than TKIP did. So allowing for down the road development, if you will. Along with this, you often saw personal and enterprise. You would see WPA personal, WPA2 personal, and WPA2 enterprise. So with the personal and enterprise, okay, the personal versions of WPA and WPA2, you would see WPA, PSK, WPA2, PSK. PSK is short for pre-shared key. Common configuration for home networks, home wireless routers, that sort of thing. You entered a passphrase for your device to authenticate to the network. The passphrase and the SSID are then used to make an encryption key, if you will, for each device. And that's how the communication would occur between device and access point. The enterprise versions of WPA and WPA2 implement additional security measures. Radius server is used in cooperation with authentication mechanisms like EAP, Extensible Authentication Protocol, EAP, Extensive Authentication Protocol. So this is really a framework for authenticating clients and servers. So the actual it works in conjunction with Radius. It doesn't actually perform the encryption authentication. It's just there to help with Radius to authenticate and authenticate users, if you will. So EAP is organized communicating with a network client, and Radius is the one that's actually handling the authentication. And EAP messages are encapsulated inside the Radius messages. So what they're trying to show you here is just that. EAP is there for the user to get to the server, and then the Radius server is there handling this part of the network here. Okay. So the three main entities, you have the supplicant, authenticator, and the authentication server. So, and they actually show you, okay, the device is talking the access point, the EAP starts, and now this actually gets passed over to the server, it's authenticated, and then we can start sending information, etc. So it's another step in trying to authenticate or secure the network, secure the communications of the network. Pretty much supported by all modern operating systems, can be used with different methods, adaptable. You usually start off as point-to-point, and now can be adapted to use on our wired networks, wireless and wired networks. IEEE 802.1x standard. You'll see that when you start doing some network configuration sometimes. So you'll see EAP TLS, and you'll also see EAP fast out here. Okay, EAP TLS here we're actually using encryption, just like HTTP uses HTTPS, the secure socket TLS. In this case, EAP is using TLS encryption to protect its communication. So the EAP communication is actually using a encryption here, using a certificate authority, and this part here then is getting encrypted, and then the authentication is occurring here like we looked at earlier, and using the certificate authority. It's certificate based, and with our protected EAP and EAP fast are all tunnel based. So the EAP TLS is certificate, and our protected EAP and EAP fast are all tunnel based. Okay. So as we take a look here, this one here, we see a tunnel around all this. So this is all now encrypted tunnel, and then the Radius encryption here. All a method to, before, if we didn't have this, this was all vulnerable out here. So this is actually trying to extend this out here, that this communication is going back and forth to the server are encrypted, and then the server can do the authentication Radius that we were talked about earlier. So trying to extend that out and increase our security the whole way out. So there's the end of chapter 10.